Hello students, today we will see the electron dot structure, that is also known as Lewis dot structure or Lewis dot formula or electron dot formula, or it is also known as Lewis electron dot structure, that is LDS. So it was first given by the scientist Gilbert Newton Lewis. It was given by the scientist Gilbert Newton Lewis. So what is Lewis dot structure or electron dot structure? It is named after the scientist Lewis. That is why the electron dot structure is also known as Lewis dot structure. In this, we will represent the valence shell electrons in a molecule. So only valence shell electrons are shown in Lewis dot structure. So the electrons are represented by the dot. So electrons are represented by dot. Non-valence electrons are not shown in the electron dot structure. If there is any excess of electrons, they are shown by lone pair of electron. Lone pair of electron means they have two electrons. One pair means two electrons. So we can say Lewis dot structure, it is based on octet rule. It shows if there is a lone pair of electron, it is shown by the Lewis dot structure, and the number of bonds are based on the number of electrons in the outermost shell. So the bonding between the atoms of the molecule we can show by the number of valence electrons in the outermost shell. We can draw Lewis dot structure for covalent compounds and coordination compounds only. So the valence electrons are involved in the bond formation, and bonds are formed by pairing of valence electrons of the atom. So this Lewis dot structure is useful to know the nature of the chemical bond. It helps in knowing the nature of the chemical bond. It also helps in knowing the atomic structure, and it also helps to know the number of bonds, covalent bond, single bond, multiple bond. It helps to determine the properties of the molecule and helps in know the chemical bond formation in a molecule. So hence we can say the Lewis dot structure, only the valence electrons we show in the molecule, and it's based on the octet rule. Let's see some examples for electron dot structures. First element I have taken hydrogen, whose atomic number, that is, it is represented by Z. It has one electron. So one electron is in the K shell, and this is the nucleus which contains neutrons and protons. Protons is equal to the atomic number. So one electron. So first shell contains, K shell contains one electron. So to draw the dot structure, the one electron is shown by dots. So this is Lewis dot structure for hydrogen atom. Another example, carbon. Atomic number of carbon is 6. Its electrons are, first shell contains 2 electrons, 1, 2, and the next L shell contains 4 electrons, 1, 2, 3, 4 electrons. So the Lewis dot structure, in this we will show the 4 valence electrons. So electrons are shown by the dot. So this is the Lewis dot structure for carbon. Nitrogen. The atomic number of nitrogen is 7. The electronic configuration will be k orbital has 2 electrons and L has 5. So 1, 2, 3, 4 and 5 electrons. So the valence electrons are 5 electrons. So these electrons are shown by the dot. 1, 2, 3, 4, 5. So this is a Lewis dot structure of nitrogen atom. Oxygen. Atomic number of oxygen is 8. Electronic configuration is 2 and 6. K shell contains 2 electrons and L shell contains 6 electrons. 1, 2, 3, 4, 5 and 6 electrons. So the valence shell electrons are 6 electrons. So these electrons are shown by the dot in the oxygen atom. So this is the electron dot structure or Lewis structure, Lewis dot structure for oxygen atom. Another example, we will take chlorine. Atomic number is 17. So electronic configuration is 287. First orbit will contain maximum of 2 electrons. Second orbit contains maximum of 8 electrons. And after that, the electrons will go into the third shell or third orbit. So K shell contains 2 electrons here. L shell contains 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Then 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6 and 7. So 7 electrons are present in the valence shell. So these electrons are shown by dot 1, 2, 3, 4, 5, 6, 7. So this is a Lewis dot structure for chlorine. So Lewis dot structure, the electrons are shown by the dots. Let's see some more examples in water. Lewis dot structure for water molecule. The water contains H2O. That is, it is bonded. You can draw the structure of water. High oxygen contains 4 electrons, 6 electrons in oxygen. 2 electrons are bonded by hydrogen atom and 2 are lone pair of electrons. So oxygen Z is equal to 8 and K shell contains 2, L shell contains 6 electron and hydrogen Z is equal to 1 atomic number, K shell contains 1 electrons. So this we can make like this. Oxygen valence shell electron is 6 electrons in the oxygen. So 1, 2, 3, 4, 5, 6 and hydrogen has 1 electron and 1 electron. So the Lewis dot structure for this is a Lewis dot structure for the H2O molecule. So this is the bond between the oxygen and hydrogen, oxygen and hydrogen. So this is the Lewis dot structure for the water molecule. Let's say for carbon dioxide, CO2. So the atomic number of carbon is 6. K shell contains 2 electrons. L shell contains 4 electrons. Means the valence shell contains 4 electrons. This is for the carbon. Oxygen atomic number is 8. K shell contains 2 electrons. L shell contains 6 electrons. Means both the valence shell. So valence electrons for the carbon is 4 and oxygen is 6. So we will make the Lewis dot structure for carbon dioxide. So we know that the carbon dioxide structure is this. It has 4 electrons and oxygen has 6 electrons. So carbon makes double bond with the oxygen so that it will get all octet electrons. 1, 2, 3, 4, 5, 6, 7, 8. Carbon got all the octet electrons. Similarly for oxygen, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Oxygen also got its octet electronic configuration and has both gases stable. So the Lewis dot structure for this we can write it as P. Then how many electrons are there? 4 electrons, 4 valence electrons. This is for carbon. Then next is oxygen. So to show the difference, I am putting like cross here. So 1, 2, 3, 4, 5, 6 electrons in the oxygen and another oxygen also Carbon has 4 electrons. Oxygen has 6 valence electrons. So when we are making the Lewis dot structure, so we have to show all the bond formation, and this you put full circle to show the bond formation. So all the electrons you enclose it. Then for the oxygen, like this you have to make, and for this oxygen again all the electrons you encircle all the electrons. So this is the bond formation between carbon and oxygen. So this is the bond. This is the bond. So here we have double bond. So one bond contains two electrons. So it has double bond. It means it has two bonds, double bond. So it will contain four electrons. So 1, 2, 3, 4. Two electrons of carbon, two electrons of oxygen will form bond, double bond here. Again here, two electrons of carbon and two electrons of oxygen, they will form the double bond here. So this is the Lewis dot structure for the carbon dioxide. So remember always what valence shell electrons are involved in the bond formation. These valence shell electrons only we show in the Lewis dot structure or electron dot structure. Both are same because the scientist Lewis first discovered this. That is why we are saying it as Lewis dot structure. Let's see another example. Hydrogen molecule. So again, hydrogen atomic number is equal to 1. It has one electron in the outermost shell. So one electron of hydrogen and one electron of another hydrogen. So this is the Lewis encircle both the electrons, and here also both the electrons. So we can say this is the bond. The bond is formed. Bond. It shows the bond formation. So as both has, if we see both has a single bond. Two electrons means one bond. Two electrons means one bond. So this is the Lewis dot structure for hydrogen molecule. Let's see Lewis dot structure for oxygen molecule. Z is equal to 8. K shell contains 2. Next shell, L shell contains 6. So it has 6 valence electrons. So see, one oxygen has 6 valence electron. 1, 2, 3, 4, 5, 6. Another oxygen. 1, 2, 3, 4, 5, 6. To show the difference between the electrons of both the oxygen atom, for one oxygen atom the electrons I have shown by dot, and for the other oxygen the electrons I have shown by the cross. Now these electrons will take part in the bond formation. So now you encircle all the electrons. This is how we make the Lewis dot structure for the molecule, and for oxygen also this. So this hole is the bond formation between the oxygen. So how many electrons, total electrons involved in bond formation are 4 electrons are involved in bond formation. So 4 electrons are involved in bond formation means it has made double bond. So you can write oxygen, oxygen. So this is how the structure of the oxygen molecule. Next we see the nitrogen molecule. Electron dot structure for nitrogen molecule. Z is equal to 7. Electronic configuration, that is K shell has 2 electrons, L shell has 5 electrons. So 5 electrons are present in the outermost shell. So we know that nitrogen structure is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It forms triple bond. If you are not able to make dot structure, just first write the structural formula of the nitrogen molecule, and seeing this you can make the electron dot structure of the nitrogen molecule. Now put one electron of one nitrogen, 1, 2, 3, 4, 5, and another electron of another nitrogen atom, this. Now the bond formation is shown by both the nitrogen. So now encircle all the electrons here, and here also encircle all the electrons. So this is the Lewis or electron dot structure of nitrogen molecule N2. So here how many electrons are involved? Here we have 6 electrons are there. 6 electrons means we have triple bond is between both the nitrogen. Both the nitrogen we have the triple bond. So this is, we can see here also. Next we will see for the ammonia. Electron dot structure for ammonia. Ammonia is NH3. Nitrogen Z is equal to 7 atomic number. Then K shell has 2 electrons, L shell has 5 electrons, and hydrogen atomic number is 1. So K shell has 1 electron. So all the valence shell electrons will show in the nitrogen. 1, 2, 3, 4, 5. Hydrogen 1 electron, this hydrogen 1, and this hydrogen 1 electron. So now see how bonds are formed. So encircle all the electrons here. This is how you have to make the Lewis dot structure or electron dot structure. This is for the hydrogen, and again this is for nitrogen and hydrogen. So this is the electron dot structure for the ammonia. So this is the bond formation. This is the bond formation. So you can also write like this: NH3, 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 and this. It has one lone pair of electron. One lone pair of electron means, one pair means it has 2 electrons. One pair means 2 electrons. And all are single covalent bond. So why it is making bond is mainly to have the octet electronic configuration to get the stability. That is why these molecules, they make the bonds with the other atom. So now if you count the electrons in the nitrogen, see 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen gets 8 electronic configuration. That is octet electronic configuration. It has attained the inert gas electronic configuration and hence become stable. Hydrogen also 1, 2 here. Here also 2 electron. In this also hydrogen 2 electrons. So hydrogen also get the stable electronic configuration, 2 electrons in the shell. So this is the electron dot structure of the ammonia. Let's see for the another example is methane. Methane, it is CH4 is methane. So the carbon Z is the atomic number. K shell contains 2 electron. L shell contains 4 electron. Hydrogen atomic number is 1. K shell contains 1 electrons. So we know that. So if carbon contains 4 valence electrons, so put carbon 1, 2, 3, 4 valence electrons of carbon. Now hydrogen contains 1 electron. Hydrogen contains 1 electron. Here hydrogen contains 1 electron. Hydrogen 1 electron. So now we are making electron dot structure. Encircle all the electrons. This is how you have to make the electron dot structure. Then this one. Then here this one, and this. So this is the electron dot structure for the methane. Electron dot structure for methane. So these shows bonds. The bonds are found between carbon and hydrogen. So if we write the structural formula of methane, so this is the structural formula of methane. So one single bond is there. This bond has two electrons, one electron of carbon, one electron of hydrogen. Again this bond, one electron of carbon, one hydrogen. One carbon, one hydrogen. One electron of carbon, hydrogen. All are single covalent bond. These all are formed by the sharing of the electrons. Next, we can see the so here all the bonds are formed by the sharing of the electron. That is, they form the covalent bond. It is formed within the molecule. But remember, the intermolecular forces are very weak. Intermolecular forces are very weak. So this give rise to what? It will give rise to low melting point and low boiling point of these compounds. Since the electrons are shared between the atoms, the electrons are shared between the atoms, so no charged particles are formed. That is why the covalent compounds are generally poor conductors of electricity. Poor conductors of electricity. Covalent bonds are poor conductors of electricity. Next, we will see the electron dot structure for ethane. Ethane molecular formula is C2H6. Same, carbon has 6 electrons. K shell contains 2, L shell contains 4, and hydrogen has 1 electron. So all the valence shell electrons are shown in the electron dot structure. So this is carbon. Carbon has 4 electrons, 1, 2, 3, 4. Then another carbon also, we will take another carbon. Another carbon, 1, 2, 3, 4. Then hydrogen. Hydrogen has 1 electron. Another hydrogen, 1 hydrogen, hydrogen electron, hydrogen electron, hydrogen electron. So now these valence electrons are involved in the bond formation. So first encircle all the electrons. All the electrons here. Then for this carbon, also encircle all the electrons. This is carbon-carbon bond. Then carbon and hydrogen bond. Encircle all the electrons. Hydrogen also. Then this. This. Again here. This. And again this. So this is the electron dot structure of ethane. Its structural formula is C hydrogen, 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 hydrogen. So all are single covalent bond, and all the bonds contains 2 electron, 1 electron of carbon, another hydrogen. Here 1 electron of carbon, another of carbon. So if you are not able to draw this structure, first you draw, and according to this you can draw the electron dot structure of the ethane molecule. So this is for the saturated compound. Let's see for the ethene. Ethene means double bond. See, this is the structural formula of ethene. So here two bonds are formed between the two carbon atoms. So it's an unsaturated organic compound. Now put all the electrons, show all the valence electrons. So carbon 1, 2 electrons. This is for carbon. Another carbon 1, 2. Then between carbon and hydrogen, 1 electron of carbon, 1 electron of hydrogen, 1 electron of carbon, 1 electron of hydrogen. So carbon has 4 valence electrons, 1, 2, 3, 4. Hydrogen 1 electron. Then again carbon electron, hydrogen electron, carbon electron, hydrogen electron. Now show the bonds, encircle all the valence electrons. Then here also encircle all the valence electrons, show the bond formation between carbon and hydrogen, the bond formation between carbon and hydrogen. Here also bond formation between carbon and hydrogen. Again bond formation with carbon and hydrogen. So between two carbon, this carbon and this carbon, we have 4 electrons. 4 electrons means we have double bond. If 2 electrons are there, that shows a single bond. So this is the Lewis dot structure for the ethene. That is C2H4. Molecular formula of ethene is this. This is the structural formula of ethene. This is the structural formula of ethene. And this one is the electron dot structure of ethene. Electron dot structure of ethene. So all the valence electrons are shown by the dots. This is how we make electron dot structure for the ethene molecule. Let's take another example, electron dot structure of ethanoic acid. Electron dot structure of ethanoic acid. Ethanoic acid, the molecular formula is CH3COOH. If you want to write the structural formula, this is the structural formula. Show all the bonds. CH3, C, double bond O, OH. So on this basis, you can make the electron dot structure. So if you draw the structural formula of the ethanoic acid, then it will be very easy for you to draw the electron dot structure of the ethanoic acid. So on this basis, you can draw the electron dot structure of the ethanoic acid. So see, how many electrons? 1, 2, 3, 4. 1, 2, 3, 4 of carbon. 1, 2, 3 of the hydrogen. Hydrogen, hydrogen, hydrogen. Then another carbon. You can take for another carbon. You can show by cross. 1 electron. 1, 2, 3. 1, 2, 3. Then oxygen. We have 2 electrons are involved here for oxygen. So 1, 2, 3, 4, 5, 6 valence electrons are present in oxygen. Then again here oxygen. So same 1 electron is used for bond formation. 3, 4, 5, 6 and hydrogen 1 electron. Now show the bond formation. Encircle all the electrons. Here all the electrons. This is how you have to make the Lewis dot structure. Then oxygen, it is also making bond with carbon and hydrogen. Then oxygen and hydrogen are also making bond. So encircle this. Here oxygen and carbon are making bond. So here you do encircle all the electrons. Then oxygen and carbon bond. Then carbon and hydrogen bond. Then carbon and hydrogen bond. Here, this. So this is the electron dot structure for ethanoic acid, CH3COH. So this is the electron dot structure of ethanoic acid. It's very easy. If you can't draw, you just draw the structural formula. On this basis, you draw the electron dot structure of the ethanoic acid. Let's see for H2S. Hydrogen sulfide. So we know that sulfur, atomic number of sulfur is 16. It comes under the oxygen family, oxygen group. So we have K shell 2, L shell 8 and M shell 6. So outermost or valence shell electron is 6 electrons, valence electron. And hydrogen Z is equal to 1, so 1 electron in the hydrogen. So now write H2S has 6 electron, 1, 2, 3, 4, 5, 6 valence electron in sulfur, and for hydrogen 1 valence electron for the hydrogen. So now this is how we have to make the electron dot structure or the Lewis dot structure. Encircle all the electrons, then these electrons and hydrogen, again these electrons and hydrogen. So this is the Lewis dot structure of the H2S molecule or H2S. So this shows bond, again this shows bond. So single covalent bond which contains 2 electron, again 2 electron. So this is the electron dot structure for the H2S molecule. Let's say for the F2 molecule. So atomic number of fluorine is 9. Electronic configuration, K shell contains 2 electron, L shell contains 7 electron. So 7 electrons are present in the valence shell. So fluorine, it needs one more electron to attain octet electronic configuration. So it shares one electron with the another fluorine atom. So this is another fluorine. 1, 2, 3, 4, 5, 6, 7. Just I'm showing with cross to differentiate between both of them. Now encircle all these electrons and this. So this is the electron dot structure of the fluorine molecule. This is the bond formation. So F and F. This. Next example we will see propanol. Propanol. Let's see the electron dot structure for propanol. So the formula is CH3 COCH3. You can write the structural formula. If you write structural formula, then it will be very easy for you to make the electron dot structure of the propanol. C double bond O C H3 H3. Now let's make the electron dot structure of the propanol. See how many electrons are there? 4 valence electron. So 1, 2, 3, 4 valence electron of this carbon. Then oxygen you can write 1, 2, 3, 4, 5, 6 electrons of oxygen. Now this carbon, again 1 electron of this carbon. Then hydrogen and carbon. Then again 1 electron of carbon, 1 electron of hydrogen, 1 electron of carbon and 1 electron of hydrogen. Then in this carbon, again 1 more carbon, 1 electron of carbon. You can write carbon and hydrogen. We have 1 electron of carbon, another electron of hydrogen, then 1 electron of carbon, 1 electron of hydrogen, 1 electron of carbon, 1 electron of hydrogen. Now encircle all the electrons like this. You have to show. Then here like this. Then here like this. Bond formed by them. Then carbon hydrogen bond. 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 And again here also. Then carbon hydrogen bond. And between oxygen and carbon. Also oxygen and carbon. Again this is the bond. So this is the electron dot structure of propanol, or this is also known as Lewis dot structure. This is how we have to make the electron dot structure for the compound propanol. Let's see another example. CH3Cl, chloromethane. It's a chloromethane, or we can say methyl chloride. So you can make the structural formula. If you write the structural formula, it will be very easy for to make the electron dot structure. Same thing, we know that carbon atomic number is Z is equal to 6. Electronic configuration is K shell contains 2, L shell contains 4. So it has 4 valence electrons. Chlorine, the atomic number is 17. Electronic configuration K shell contains 2, L shell contains 8, M shell contains 7. So it has 7 valence electrons. So now we will make the electron dot structure for methyl chloride. First carbon, how many electrons valence? 4 electrons or valence electrons of the carbon, write down. Then hydrogen has 1 electron. So 1 electron of hydrogen. Again 1 electron of hydrogen. 1 electron of hydrogen. Now this carbon make bond with chlorine. So chlorine, how many valence electrons we have? 7 valence electron. It needs 1 more electron to make octet in the outermost shell. So 1 electron here I am showing, and put all the 7 electrons for the chlorine. Now show the bond formation between carbon, hydrogen, carbon and chlorine. So this is how encircle all the electrons here, all the electrons here, then bond between carbon and hydrogen, and bond between carbon and hydrogen. So this is the electron dot structure of chloromethane or methyl chloride. Let's see one more example. Electron dot structure for cyclopentane. We will see for cyclopentane. Cyclopentane. So how we will write the structure? 1, 2, 3, 4, 5. And carbon is tetravalent, its valency is 4. So it forms bond with, each carbon forms bond with 2 hydrogen, and 2 other electrons form bonds with the carbon. Carbon, hydrogen, carbon and hydrogen. This is the structural formula for cyclopentane. So you can write what is the molecular formula. C4 is C5, because it's a C5. And how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Now we will make the electron dot structure for the cyclopentane. See how many electrons? 1, 2, 3, 4 electron, 1 electron of hydrogen, hydrogen. So like this you can make 1 electron of carbon, carbon, then carbon, then carbon. So carbon electron is there. So 1 electron of hydrogen. Again 1 electron of carbon, 1 electron of hydrogen. So this. Then again this carbon you write 1 electron of this carbon, then 1 electron here, then 2 electrons, 1 electron of carbon, 1 electron of hydrogen, 1 electron of carbon, 1 electron of hydrogen. Then this is bonded with this carbon, again 1 electron here, then 1 electron of carbon, 1 electron of hydrogen, 1 electron of carbon, 1 electron of hydrogen. Then this carbon is bonded with this carbon. So right here 1 electron of this carbon, again carbon and hydrogen, carbon and hydrogen, 1 electron of carbon. 1, 2, 3, 4, and one more carbon. It is this. One electron of this carbon, then one carbon, one hydrogen, one carbon, one electron of hydrogen, and again one electron of this carbon. Now you have to encircle all these, show the bond formation. So now like this you have to show these electrons, then this, then this, then again here see how electron bond is formed between them, these electrons. Then here you can see how bond is formed. Then make it proper circle, that will look beautiful. Then here the carbon, how it is making the bond with this carbon. So here see how you are making this, then carbon hydrogen bond here. Okay, then again here you can see all electrons. This is this, this is this. Then here also between carbon and hydrogen. So you can make it as, and this is here 2 electrons, carbon this and this, and 1 electron this is. So this is the electron dot structure of cyclopentane. So this is molecular formula, this is structural formula, this is electron dot structure of the cyclopentane. So again here see one bond, so you show here one bond has 2 electrons. So you check all the electrons here, 2 electrons, one of carbon, another of carbon. So one bond we have 2 electrons, again one bond, this is 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 bond, bond formed here, again bond formed here bond. So remember one bond has 2 electrons. Just you check whether you have drawn correct or not. So these bond, wherever the bonds are formed, it should have the 2 electrons. If it has 2 electrons, then you have made the electron dot structure correct. Otherwise, again you adjust and draw the structure. Next important, one more important is the electron dot structure of sulfur, which is made up of 8 atoms of sulfur. Electron dot structure of sulfur, and this sulfur is made up of 8 atoms of sulfur. So sulfur, the atomic number is 16, electronic configuration 2, L8 and M6. So it has 6 valence electrons. 6 valence electrons in the outermost shell, that is the valence shell. You know the structure of sulfur is crown shaped structure of sulfur, like this we have. This is the structure of the sulfur. Sulfur, 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 and sulfur. So count 1, 2, 3, 4, 5, 6, 7, 8. It has 6 valence electron. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So you can okay, 1, 2, 3, 4, 3, 4. This is 1, 2, 3, 4, 5, and 6. This is the horn shape of the sulfur. Now we can make the electron dot structure of the sulfur. So first one sulfur you draw here. So how many electrons it has? So it is just you can see this and you can make 1, 2, 3, 4, and one electron of one sulfur, one electron of another sulfur. Then again here one electron, one electron of another sulfur, 1, 2. How many electrons? 1, 2, 3, 4, 5, 6. And again here one electron. So 1, 2, 3, 4, 5, and here 6. One electron of this sulfur. 1, 2, 3, 4, 5, and this sulfur. Again this sulfur electron. Then we have 1, 2, 3, 4, 5, 6, and another sulfur electron. This. Then another sulfur. This sulfur electron. 1, 2, 3, 4, 5, and 6. Then another sulfur. This electron 1. Then 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have to write two more sulfur. So one electron of this sulfur. Okay. Then 1, 2, 3, 4, 5, and 6. Then another sulfur 6. 1, 2, 3, 4, 5, 6 electrons. So you can make it as here. Now encircle all the electrons. This. Now see the bond formation. How? Then this. Then this one. Then this one. Then this one. Then this one. Then again. So both the electrons. So this one. So this is the electron dot structure of the sulfur. So it's very easy. You first, if you feel that it is hard to draw the electron dot structure, then first you draw the structural formula, and on that basis see the valence electrons, and on that basis you can make the electron dot structures. Thank you very much.